Welcome, Year 10. We're going to be looking at the quadratic formula today. You've seen it before, and it's fantastic. If you have trouble getting the roots of the equation and you try the little AC and the B tree and you just can't come up with factors, you can always revert to this. And remember, if it is positive under the square root sign, there is two solutions. If it is negative under the square root sign, there is zero solutions or zero real solutions. For those that do specialist maths, you'll see that there actually are solutions, but they're pretty special. And if it is equals zero, then there is one solution. So the value underneath that square root sign is actually quite vital to how many solutions we have, if you can remember that from previous lessons. So because you've seen it before, I'll do a couple of examples and then let you go. I'm only getting you to do a few because this is a refresher. Okay, the first thing is to get it in the form of ax squared plus bx. I went to write b there, what's a silly duffer. And then plus c, in this case c becomes minus 1, moving the 1 to the other side. So we now have it in our form, ax squared plus bx plus c. Substituting it in, x equals negative b. B is 8. Plus and minus, that's indicating two possible answers. The square root of b squared, so that's 8 squared, minus 4 times the value of a, which is 2, times the value of c, which is minus 1, all over 2 times the value of a, which in this case is 2. Negative 8 plus or minus the square root of 64 minus, two minuses make it a plus, plus 8 all over 4. Now it's asked for it in exact values, so we need to leave it under the, or simplify the square root. So it's the square root of 72 all over 4. Now I know some people love surds and some people don't. So let me help you out with this. Remembering the easiest way to do it is to think of what are the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64. Now I'm looking for the largest square that is a factor of 72, that goes into 72. 64 is of course too big, 49 is too big, 36. 36 times 2 is 72. That makes it a bit easier. So negative 8 plus or minus the square root of 36 times 2 all over 4 becomes 8 plus or minus square root of 36 is 6 root 2 on 4, and I'll just use a different color. I'm going to divide everything by 2 because I can. If I divide something into a sum, I need to divide it into all terms of the sum. So that's how we simplify. I'll just shrink that so it fits in. And so now I can say my solution, and I'll use the blue again, equals 4. So 4 plus 3 root 2. And if you're watching, I've actually just fixed that up because I did make an error. And that's my symbol for and. 4 minus 3 root 2 on 2. And they're my two solutions. Exact values, we leave them as surds. In question 4, it's wanting us to actually find the x-intercepts, if they exist, axis of symmetry, turning point, and sketch. So it's basically what we're doing in the last exercise, but using the quadratic formula. So to find the x-intercepts, remembering that that's when y equals 0, so 0 equals negative x squared minus 3x minus 1. You can try the AC thing, it's not going to work with this one. So x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. B is negative 3. Don't forget, it's not just 3, it's the value or the sign in front of it. So it's negative 3 plus or minus the square root of negative 3 squared. Now be careful with the use of calculators. If you typed in negative 3 squared, it would give you the answer of negative 9 because it's only squaring the 3 and not the negative sign. So it's something to be aware of. Putting brackets around the negative 3 will fix up that calculator usage problem that some people have. Minus 4 times A is negative 1 and C is negative 1. All over 2 times negative 1. Simplifying becomes 3 plus or minus the square root of 9 minus, so it ends up 9 minus 4, all on negative 2. And so I get 3 plus or minus root 5 all over negative 2. And so therefore my value, I might actually take the negative to the top, and so make that negative 3 plus or minus, swap those signs upside down. Doesn't really make that big a difference. And so my two values are negative 3 plus root 5 on 2, 0, and the other one is negative 3 minus root 5 on 2, 0. So just give us a bit more room. Okay, go to a different color just because it's in a different column. And let's try to think of what we've got so far. So far we've got negative 3, and this is where you've got to try and think about it. Negative 3 plus root 5. Well, root 5 is in between 4 and 9. It's going to be close to 2. So if I go square root of 5, just to see what it is, it's 2.2. So it's basically 3 plus 2.2 on 2, and minus 3 minus 2.2 on 2. So here we'd end up with negative 0.8 on 2, which would be negative 0.4 approximately, and this would be negative 5.2 on 2, which would be negative, what's that, 2.6. Okay, so we've got negative 0.4, so if I go negative 1, negative 2, negative 3, so negative 0.4 about there, negative 2.6. Remember, we're talking about sketching, we're not talking about absolute perfection. Now we've got to try and work out where is the halfway point. Now I'm going to use that other system to find the turning point, to say the turning point of x is negative b on 2a. And so in this case, it becomes negative 3, all on 2 times negative 1, which gives me a value of negative 1.5, or negative 3 over 2. Therefore, y equals negative 1.5 squared minus 3 times negative 1.5 minus 1. Of course, with the numbers like this, you would expect that you could use a calculator to do these and not have something like this in a non-calculator test. So just typing it away, I'll pause. So welcome back. According to my calculator, it is 1.25. So the turning point is negative 1.5 and 1.25. Makes sense because it should be a SAD graph because it's a negative value in front of the x squared. The other thing we need to work out, and it's not hard to work out because you just need to see it, the y-intercept is simply negative 1. Y-intercept equals negative 1. So that is 0, negative 1. Putting it all together, so there's negative 1, negative 1, positive 1, positive 2, our y values, our x values. We have negative 1.5 is our turning point x value, and its y value is 1.25. Remember, it's a sketch. Okay. And we have our parabola. Okay, well, enjoy those questions. I won't keep going on about it. It's using your calculators and a bit of a sketching question for reinforcing what you've done. So again, I've put a number there. I haven't put too many, so it shouldn't take you too long. I would expect this to be done in a single lesson. Okay.